My presentation is about cybersecurity for critical infrastructures, and in some way it's very well connected to the previous one, because we saw which are some of the drawbacks of the actual technologies in this field, and maybe that this presentation could be some guideline to understand which could be the future of in this field. What is the future? Okay, we already talked about these topics in the previous presentation. We understand, of course, that critical infrastructure represents the backbone of our society. We already talked about border control, it's quite important point. We talked about territory protection, transport, communications, and so on. Also, electricity, water, and all these kind of things are particularly important in the sense that we need to have continuous availability of these services. It's not possible to have these services stopped even for some short period of time. And the problem is that nowadays we have all these infrastructures connected not only to public networks, but also to the internet, which is a particularly, in some way, vulnerable point. And in fact, we already talked about this. How much easy is the work of people who want to perform some criminal actions also against this type of structures. And the problem is how to counteract this risk. There is some architecture that is particularly useful for design systems for countering cyber crime. This architecture, this is only a logical diagram of this architecture. Don't assume that we are talking about something that is concentrated in some way. This is a distributed architecture. The logical things that we learn from this graphic is that in order to perform some prevention of cybercrime, we need a lot of things together. We need to have something that belongs to the traditional defense systems, not cyber in the sense of cybersecurity. When we talk about sensors, we talk about traditional systems to prevent physical intrusion, for example. So we need this kind of system as well. We need some new kind of systems that we will explain better during this presentation. And these systems have to work both in non-real time and real time to take some actions that is necessary to prevent criminal actions. We also have a lot of intervention from human beings. For example, intelligence. Intelligence is quite typical object related to the human being, more than to the machine, but also to the machine, of course. And this part here, the human in the loop. We will see better these details of this architecture during the presentation. The main problem is that when dealing with these systems, we have to cope with some kind of data which are heterogeneous. We have different kind of data of different types, different sources. And some of these sources are other machines, other are human sources. For example, intelligence is human sources. And the point is that many of these data travel through public networks and specifically through internet. And most of this data, at least in our idea of countering cybercrime, and I remember that this has been also mentioned in the previous presentation. Most of this data to detect cybercrime travel through social networks. This is quite important. The problem is, in general, that in order to design systems which are really effective, we have to apply new technologies, and this is the main subject of this presentation. Some other points that are quite important. When preventing cybercrime, the most important point is that we have to discover the cybercrime before it is effective. So usually it's not so important to discover the cybercrime after it has produced some effects. We have to discover before. And the idea is to use most data of social networks in order to do that, together with other data coming from intelligence. And in particular, also to detect criminal actions and also to localize, this is another important point, to localize the cybercriminal. It is not only important to understand which are the threats that we are going to counter, but also where they originate. So, some assumption of this presentation is that we have to include these 5 technologies: big data, intelligence, human in the loop, deep learning, data fusion. In some cases, some of these technologies have already been applied. And I will say something about that. But not all of them, and not in the best way. Big data, all of us know which are big data because everybody has to cope with big data every day, for example, accessing Google and so on. The main concept of big data is that we have to analyze a large volume of data, a large volume in the sense that is not a quantity of data that we use day by day. They are quite a big amount of data that is not manageable with usual technologies. So we require big capacity of processing. And the main algorithm to do that is the MapReduce algorithm that is used by Google. The main concept is that of processing this data in parallel, map, and this data have to be reduced before processing. So the significance of the triangle that I showed before in the architecture is just like this, that we start from non-real-time data that are not good for processing to real-time data, which allow ourselves to output data in real time in order to really prevent the criminal actions. Okay, I will go a bit fast about the attributes of big data. The attributes are, first of all, the volume. The volume, it's important to have a big volume of data to extract the patterns that are important for us. But it's also important to have variety of data. So if we have only one kind of data, this could be not so useful. We have to gather many kinds of data, and I said before, this is usually done by using data traveling through the social networks. Velocity of data is another important point. We can compress or expand the data as much as we need in order to perform real-time actions. And most important to us is the value of data. The value of data is the real contents of data which can allow ourselves to understand the essence of the threat that we are dealing with. The use of metadata has already been done, for example, to detect attacks happening at a short distance of time. And I just mentioned a case study, this one. We had a main attack in May 2015 in the US Office of Personnel Management. The hackers succeeded in stealing 21 million, the information of 21 million people. And after only 2 months, a similar attack was performed towards the Pentagon. This second attack was practically stopped very, very fast because of the experience gathered from the previous one. These were very similar cases. So in the case of Pentagon, no classified information was stolen, and only a minor damage was produced to the plant. This demonstrates two things. First of all, that learning by means of metadata from one cyber attack, we can prevent the other one. The second point is that, as I mentioned before, the origin of the attack. Both these attacks were not made by individual hackers. They were made with the help of governments. So this is quite very important thing to think about. Okay, we go to the second point, intelligence. Intelligence is a set of processes which are aimed to understand the characteristic of the adversary element. Intelligence has been a quite productive element in defense, for example. We understand what the adversary can do by means of intelligence. So this is mainly a human technology, just to say. But of course, we also have artificial intelligence, which is the same thing or similar, made by machines. With real experiments, we understood that coupling human intelligence with machine intelligence is quite important. Why this? Because if we work with unsupervised machine learning, even if machine learning is quite effective in general, the drawback of machine learning, at least in cybersecurity, is that it produces continuous alert activity. And the consequence of this is that there is a decrease of attention. Because if we have continuous alerts over time, we lose the control. It may be that we give less importance to the future alerts. So one point is that the connection of machine learning with human learning could be the right way to solve this problem. And in fact, this is an idea which has been developed by the MIT, is a human interactive machine learning, is a mechanism which complements cognitive science with human intelligence. There is a structure which passes from the human intelligence to machine through the formulas and then goes back to human intelligence. Okay, sorry. That point is human in the loop. Human in the loop is a process which is required when we have to take some critical actions, and this particular process is not adequate for machine decision. So it needs a judgment from human being. Why this? The same, we learned from the practical systems. When we use only machine learning systems, the drawback is, as these are based on the anomaly detection process, they cannot distinguish between high level of risk and low level of risk. So usually the estimation of the rank of the attack is better made from human beings instead of a machine. And this is the reason why we put the two processes together. We have a case study also in this. This is a project conducted by the MIT as well, with a company, the Pattern X. They already coupled the human intelligence with the machine intelligence. They called this system artificial intelligence and analyst intuition. They applied this system to cybersecurity, and the result is that the performance of the system resulted 3 times better than modern automated cyber attack detection systems. And at the same time, they reduced the false alerts by a factor of 5, with respect to the best cyber detection systems. So they obtain very good results by applying this concept. So, just to conclude about human in the loop, we can say that as traditional information security systems are based either on unsupervised machine learning or on analyst-driven solution, by applying a human in the loop, we can couple together these approaches and obtain best results. The fourth technology is deep learning. Deep learning is basically a set of algorithms which model data transformation and try to find new patterns in the data that are analyzed by using the same model of the human brain. So the concept is that we have many layers inside the structure of deep learning. This is the difference between deep learning and neural networks. No? And these characteristics allows to identify new patterns in the data that we are analyzing. Moreover, deep learning is also very resistant to noise and can detect more malware than other machine learning systems. We have a case study also on this. There is a Deep Instinct, is a company from Israel, a startup company, which works in cybersecurity. They already apply deep learning in security systems. And they demonstrated that they can improve detection of cyber threats by more of 20% with regard to the most advanced security software. So the emergence of deep learning demonstrates that we can do much better by applying this technique. And in fact, many large companies and startups are going to use this kind of technology. The last one is data fusion. Data fusion is the process of integrating and merging multiple data, different data and knowledge in order to extract information which are in some way concealed inside this data. This is quite a picture which demonstrates the possibility of data fusion. There is a worldwide accepted definition of data fusion which defines different levels at which data fusion can be applied. And this definition has been provided by the joint directors of laboratory. So these, depending on the Department of Defense in US. These levels are 5. We go from the low-level signal information data processing to the association, correlation, pattern recognition, risk evaluation, resource management. So we have all these usually in a data fusion structure, or we can have some of these. Data fusion has already been applied in cybersecurity systems, for example, in intrusion prevention systems. However, some phases of data fusion are the candidate components for a cyber system for critical infrastructures. Good. So, to conclude about this discussion of technologies, it is quite certain that the importance of critical infrastructures in modern life requires the protection of these structures against cybercrime. An efficient cybersecurity system for critical infrastructure protection must be based on the modern computer and communication technologies. To analyze these technologies is quite important, and is important in order to define the guidelines for an efficient design of cybersecurity systems. Overall, we can say that in order to design a cybersecurity system for the defense of critical infrastructures, we need to couple human technologies, if the term could be used, with machine technologies. This is the best way to go towards the right direction. And this concludes my presentation. Thank you.